Right, in this unit, we are investigating the concept of the object in a object-oriented programming system. As I talked to you before, an object is a concept for your programs, and it encapsulates the variables and the methods that you need in your code for that concept. A concept might be a clock, which is what I've made here with clocks objects. So when we have an object, it manages the code for that object, and that object is then used in other programs. So let's look at the clocks object itself. I've put the three files into your shared drive. It is in your assignment descriptions clock object code folder. We have three files. Two of them are object-oriented programming, and one of them is procedurally oriented programming. And you'll see that the object-oriented programming organizes the code in such a way that the code is elegant. Does someone know what the word elegant means when applied to code?
It doesn't hurt your eyes.
Doesn't hurt your eyes. It's pretty. That's very good. Okay, anyone else? I'm sorry, I cut you off. What does elegant mean? Elegant when it applies to code. Someone says that code is elegant. It's neat. That's great. It's neat. Properly arranged. What about the code itself? What about the efficiency of the code?
It's very easy to read.
It's very efficient. So the code is easy to read as a programmer. It's very efficient, so it goes real fast. And it's very small. It doesn't use much memory. So that is elegant code. You'll see if you look at these files, when we create the code, that object-oriented programming code is elegant, and procedurally oriented coding is a piece of crap. So let's look at object-oriented programming, and we'll look at the object. So I'm entering the clocks object file, and all I have here are some comments right now. With the design objective, here we're identifying the concept of this clock object. And this is what we want to do. We have three clocks. The clocks can show times in hours, minutes, and seconds. The clocks can be set to show hours in 24-hour clock or 12-hour AM, PM clock. So we have to print these clocks. The clocks can have their time set using setters. We'll talk about setters later. And today we're learning about constructors. We want to be able to set the hours, or set the minutes, or set the seconds, or set the total seconds in the whole time. It defaults to 12 AM or 2400 hours. The clock seconds display at 0 to 59. The clock's minutes are to display at 0 to 59. And the clock's hours are to display at 1 to 24 or 1 to 12, which is very much like the clocks that you're familiar with. The clocks can add more hours to the clock to get a new time. Clocks can add more minutes or more seconds. The clocks can add another clock to them and change their time. So this is the concept we're shooting for. We're defining what the concept is. If we go back to the project, in the test driver, we want to make sure this clock object that we created works properly. And so the black box test must test everything we want the clock to do. So in the black box text, I'm going to make three clocks. We're going to set a clock to 24 hours and print it, set another clock to 24 hours and print it, and reset the hours, minutes, and seconds of a clock and print it to make sure our setters work. Add more seconds to a clock and print it. The seconds added could change the seconds only. So if we have less than 59 seconds and we add enough to make it stay less than 59 seconds, there's normal additions. Seconds added changes seconds and minutes. Now we've rolled over seconds. We're now above 60 seconds. So we need to up the minutes by 1 and return our seconds to the right area. Or the seconds added changes minutes and hours. We add so many seconds that our hours change. And what happens when the hours added passes by that 24-hour limit? We have to make the clock handle all these events. And we're going to test them in the black box testing. So this brief example shows us what a clock object is. The concept of object is a concept of code. And we see that we're going to need two Java files, one for your main, and here the purpose of my main was to test my clock object. So I've enabled this one, the clock object test driver, and that contains the main code. The other one is the clocks object itself, and that contains the concept of the clock and the code that is all needed for a clock. Now I'm going to give you a brief view of what I've done so far. So I've been working on this on the own, and eventually I'm going to ask you guys to make this clock itself. So here's my clock test driver using the clock object-oriented programming. I don't know if you can see this, so let me make the text bigger for you. Increasing the size of the text, whoopsie. Increasing the size of the text. So here we see the same kind of pattern. Make 3 new clocks and print them. So here I make 3 new clocks using the syntax in Java to make objects. We have the class name, the instance variable name equals new, and we call it a constructor of the class. Then we print them. And all I do to print is to pass the class variable to println. And how does println actually print a clock? Println has no idea a clock exists. One of the strange things in Java is that let me write that up here in comments, right here. All objects, remember what an object is now, aka class, in Java inherit from the object class. The object class has a method to string, and if a method such as println needs a string to print, the toString method that every Java object has is called. So here I'm printing the clock because all my clock's objects have a toString method. If they did not, we would still print the clock using the Java object's toString method. So this is an instance where the toString method is overloaded. This allows it to print. But let's look at the code. And let's see, does the code look elegant or not? I make clocks. I print them. You just throw the clock at the printer. I set the time. Set milliseconds false. So now it's military time. Or it's not military time. Set hours. Set minutes. Set seconds. And so all I'm doing here is passing hours, minutes, and seconds. What else can we do? Set hours, minutes, seconds. Set with another clock. I'm calling this set function. This makes sense to set the clock. If we run this, we can see the output. And this is a black box test. Make 3 clocks, they're all 24 hours. Set 24 hour to 12 hour, now it's 0 p.m. Set hours 33, so it changes the clock from 24 to 9. So 33 rounds to 9. That's actually 9 a.m. if we set it to an AM PM clock. Add 73 minutes. 73 minutes is 1 hour and 13 minutes. So we have 1 hour and 13 minutes. 9 becomes 10:13. Set minute 73 and so on. Here's an overall set. 6 hours, 34 minutes, and 153 seconds. So 153 seconds can't fit in a second, so it rounds it up. Set to this new time, 10:27. Lo and behold, it worked. This is an AM PM clock being set with a 24-hour clock. The time itself is the same for both clocks, but the way it's printed is different, and that's the 24 hours. And so this code comes out, the output is very pretty, does what we want, and the code itself is elegant. I also have procedurally oriented. Let's see if I have this thing working. And procedurally oriented is a god-awful mess. I need 3 clocks, so I need 3 sets of hours, minutes, and seconds, 1 for each clock. What a mess. I can just make 3 clocks and have all these things in it. Print them, right? I need to print the hours, and then I need to print the minutes, and then I need to print the seconds again and again and again. It is a god-awful mess. And so this concludes this little demo. The demo is trying to show you that objects make programming easier for you. Here's the object that I actually made. We have hours, minutes, and seconds. Every clock has its own hours, minutes, and seconds. These are non-static variables, which we'll talk about today, or you'll find out about today. Here's the print method, toString. So any hours it's going to print, is it military time? Yes, print it as military time. Otherwise, convert it to AM, PM time, and so on. So we do all our work here in the object. The object can be inherited into any driver. Object. It's all right there, all that code right there. This concludes this demonstration. Are there any questions?
Do you have to import the class for object?
Okay, so the question is, do you have to import the class for the object? If the two files, the class object, the object file, and the driver file are in the same project, then no. But if your object file is in a library, then you do have to import it. Many of you have imported scanner, and scanner is in a different library. That scanner object file is not in the same folder as your project or your program, so you had to import it. Here, the two are in the same file or folder, so you do not have to import it. That's a good question. Any other question? Okay, go ahead and continue working on your thing. Again, right now you just have the notes for the clock object, and later I'm going to give you a demo of the clock object, and then even later I can give you a test to see if you understand how objects work. All right, thank you very much.